Hi everyone, welcome to IGCSE Seminar 2020. I am Ms. Jarina, and in this video, I shall walk you through some of the essential components of Chemistry 0620. For the first part of the video, I shall discuss the papers that each candidate sits for. Then we shall look into subject content, and lastly, there will be some tips and tricks on how to answer questions better. So stay with me and let's get started. All chemistry CRE candidates take 3 papers. We in SGIS do papers 1, 2, 3, 4, 5, 4, and 6. 1, 2, 3, 4, and 6. That is, the core candidates do papers 1, 3, and 6. Extended candidates do paper 2, 4, and 6. Core candidates will be eligible for grade C to G, and extended candidates will be eligible for grades A star to G. Paper 1 is a multiple choice paper. There are 40 questions with 4 choices. You must record your choices using a soft pencil on a separate answer sheet that will be provided. 30% of your total marks comes from this paper. A useful tip for paper 1, out of the 4 choices given, many times you will find that 2 are totally incorrect. Cross out the choices and choose between the other 2. This will help you to save time and also minimize errors. Duration for paper 3 or 4 is 1 hour and 15 minutes. This paper consists of short answer and structured question. Total marks for this paper is 80. 50% of your overall marks comes from this paper. You will be tested on chemistry concepts, definitions, theories, chemical symbols, chemical instruments and apparatus, chemical calculations, etc. You may also be asked to use information to identify patterns, make predictions, as well as present information from the topics learned. Some tips for paper 3. Most important is to read the question carefully. If the question says give 2 observations apart from temperature change, do not write about temperature change in your answer. No marks will be given. In questions related to stoichiometry or chemical calculations, show all workings in your answer. Make sure your answer has the same number of significant figures as the data given in the question. Avoid vague statements. For example, if the question asks about the use of graphite, the answer should be graphite is used for electrodes in electrolysis. Do not just write graphite is used in electrolysis. That would be considered as a vague answer. Next, for papers 1, 2, 3, and 4, a copy of the periodic table will be found in the question paper. The duration for paper 6, which is alternative to practical, is 1 hour only. Total marks is 40. Questions are based on experimental skills. In this paper, you can expect questions on labeling apparatus, testing of ions, flame tests. You will also have to complete tables of data. You need to draw and interpret graphs. And you also have to answer questions based on planning investigations. 20% of your total marks comes from this paper. General tips for paper 6. Make sure your answers do not contradict. For example, you cannot write a white insoluble precipitate dissolves, because insoluble and dissolves, they have opposite meanings. Now, when you plot a graph for rate of reaction, make sure you draw a curve of best fit. Do not include anomalous result when you draw the curve. Now, if you're asked to draw diagrams, make sure you fill up the space that is given. That means you draw big enough and you label the diagrams. And if you're asked to draw apparatus for gas measurement, make sure the diagram is drawn in such a way that the gas does not escape. All candidates who are doing chemistry 0620 study the following topics: the particulate nature of matter, experimental techniques, atoms, elements and compounds, stoichiometry, electricity and chemistry, chemical energetics, In chemical energetics, you learn about endothermic and exothermic reactions, bond energies, etc. Chemical reactions, acid bases and salts, the periodic table, metals, air and water, sulfur, carbonates, and organic chemistry. Now, so let's get into the details of the subject content. Before that, watch a video on the best 9 scientific ways to study.
No surprise that many of us are determined to study smarter instead of longer. But which study tips and tricks actually work scientifically and can help you get those perfect grades? First up, research shows that study sessions are most effective in small, short chunks. Instead of cramming in a 10-hour study session, it's much more effective to spread it out into 20, 30-minute sessions over a few weeks. This is because your brain is better at encoding information into the synapses in short, repeated sessions as opposed to one large one. And this is why even learning different skills, whether it's swimming, tennis, or a singing lesson, often follows this same format. And while cramming and pulling all-nighters may be a ritual, it turns out that this is linked to the lowest grades. After prolonged nocturnal study sessions, reasoning and memory may be negatively affected for up to 4 whole days. Instead, setting up specific times in a day or during the week just to study primes your brain by creating a routine, and over time, studying actually becomes easier as your brain is trained to learn in those moments. And while many of us spend hours passively rereading our notes or highlighting a textbook, studies have shown this to be ineffective. It doesn't improve your understanding of topics, nor does it link key concepts together. It can even be detrimental as it draws your attention to less important information. Flashcards, on the other hand, are proven to be excellent memory reinforcement tools, whether during your scheduled study times or during off times like a bus ride home. It also helps to have a specific goal for each study session. Instead of aimlessly studying, pick one aspect you'll focus on, whether it's balancing chemical equations or learning how to conjugate French verbs. If you can't explain it simply, then you don't understand it well enough. In studies where individuals were asked to learn a passage and then half were told that they would be tested on the material while the other half were told they would have to teach it to other students, participants expecting to teach it did much better at understanding the main points. When you're expecting to teach, your brain organizes the information in a more logical, coherent structure. Of course, practice, practice, practice. Not only do practice tests put your brain in the environment, but even if you make mistakes, they help identify gaps in your knowledge. Practice tests have also been shown to increase confidence, thereby leading to better performance. So, where should you be studying? Research shows that having a designated sacred spot for study that's well equipped with every tool you might need is best. Just like setting times, this primes your brain for studying. Have an awesome study playlist? Not so fast. While some studies have shown that certain types of classical music can help improve concentration, a recent study has shown that learning with rhythmic background noise can be detrimental to focus, and those not using music fared much better. And if you haven't already, put away your phone. This is a no-brainer, but your texts and social media notifications severely decrease concentration. Of course, exams can be extremely stressful, so if you want some tips on how to deal with exam anxiety, check out our ASAP Thought video, which breaks down some tips for that.
Hope from watching the video, you picked up 1 or 2 ways to improve your revision skills as well. Now let's pass on to the areas to concentrate. I shall give you a summary of what you need to focus on for each type, for each topic. You can refer to your copy of the syllabus content for a detailed view of the contents. We begin with the particulate nature of matter. You need to describe the arrangement and motion of particles in solid, liquid, and gas. You also need to explain Brownian motion and rate of diffusion based on the molecular mass of the particles. As for experimental techniques, you should be able to label apparatus correctly, interpret chromatograms, and outline how chromatography can be used to identify colorless substances using locating agents. You also need to know how to calculate the RF value. Under methods of purification, you need to know about filtration, crystallization, distillation, etc., and suggest correct purification methods for substances that are given in the exam. You need to know about the differences between atoms, mixtures, and compounds, as well as the differences between metals and non-metals for the topic that you see on the screen, which is atoms, elements, and compounds. You should be able to draw diagrams for ionic bonds, covalent bonds, and metallic bonding. Students should be able to describe the macromolecular structure of silicon for oxide, diamond, and graphite, and relate it to the property. Questions on metallic bonding commonly appear in the exam. Students should know what metallic bonding is and how this is related to the electrical conductivity and malleability of metals. Let's move on to stoichiometry or chemical calculations. Now, in this topic, you have to construct and balance equations. You need to know about the mole and Avogadro constant. Calculations based on stoichiometric reacting masses, volumes of gas, and solution are quite common in IGCSE exam. It is good that you practice them well and know all the formulae related to this topic. Learning the formulae will help you answer questions of this kind. Students should also be able to calculate empirical formula, molecular formula, percentage yield, percentage purity from the data given. When answering questions that involve calculation, you must show your working. This will enable the examiner to follow your working, and you will be given marks where needed, even if your answer is not correct. Electricity and chemistry. You should be able to describe what electrolysis is, predict the products of electrolysis at the cathode and anode, as well as write half equations at the anode and cathode. You should also be able to answer questions based on simple electric cells. The extraction of aluminium by electrolysis is also a common question that is asked. The electrolysis of brine and refining of copper come under this section. In chemical energetics, you need to answer questions based on exothermic and endothermic processes, draw and label energy level diagrams, and calculate energy of a chemical reaction using bond energies. When defining rate of reaction, remember 2 points. It is the change in volume, mass, etc. over a fixed period of time. Do not omit the time from the answer. You should be able to describe the different factors that affect the speed of a chemical reaction, such as temperature, particle size, catalyst, concentration, enzymes, etc. You should know the concept of equilibrium to answer questions based on equilibrium reactions. A common mistake is to say that in an equilibrium reaction, a catalyst increases the rate of the forward reaction more than the reverse reaction. If a catalyst can increase the speed of the forward reaction, it can also increase the speed of the backward reaction. So catalyst has no effect on the equilibrium position of a reaction. Acids, bases, and salts. You should know that acids are proton donors and bases are proton acceptors. You should be able to define strong and weak acid, classify oxides as acidic, basic, neutral, and amphoteric. Questions about the different methods of salt preparation are very common in both paper 4 and 6. Study the different methods and you'll be able to really score well. Do not confuse the pH scale with the degree of acidity. The more acidic the substance is, the lower the pH. As I mentioned earlier, a copy of the periodic table is given at the back of the theory papers. It is important that you know the layout of the table and the information about proton number and relative atomic masses. Groups are the columns down the table. Periods are the rows across the table. And the first period only contains 2 elements that are hydrogen and helium. Metals. Students should learn the reactivity series well to answer a large range of questions in terms of reactivity, extraction of metals, etc. The industrial process such as extraction of iron from hematite, conversion of iron to steel, extraction of zinc from zinc blende, purification of impure copper are commonly asked questions. Learn the properties of transition metals well. When you're asked about specific properties of transition metals, don't list general properties of metals such as shiny, malleable, etc. Instead, you should write that transition metals form colored compounds. They're used as catalysts. So that should be your answer. Of course, knowing the properties of metals and non-metals is very, very essential for chemistry. Air and water. Students should be able to describe the manufacture of sulfuric acid by the contact process with correct balance equations. You should remember that sulfur dioxide is not used to make wood pulp, but it is used to bleach wood pulp. The Haber process is also another commonly asked question. Do not forget to revise the carbon cycle and learn the equation and the definitions for combustion, respiration, photosynthesis, etc. Carbonates. You need to describe the reaction and uses of calcium carbonate, like how calcium oxide is made from calcium carbonate, etc. You should know that the chemical reaction involved in making lime is thermal decomposition. You should also be able to describe the uses of lime and slaked lime. Organic chemistry. Coal, oil, and natural gas are fossil fuels, and natural gas is largely methane. You should be able to describe how petroleum is separated into useful fractions by fractional distillation. You should also be able to describe homologous series in detail and know about the properties of alkanes, alkenes, carboxylic acids, alcohols, and esters. You should be able to name and draw the structure of alkanes, alkenes, alcohols, carboxylic acids, esters, 1,2-dibromoethane, polymers, and isomers. You should know what macromolecules are and the chemistry of synthetic polymers such as nylon, terylene, polyethylene, polypropylene, etc. It is important for you to know how to work out the structure of a polymer from a given alkene. You should also know how to work out the structure of an alkene monomer when you're given the structure of a polymer. So this is the structure of terylene. For the exam, drawing the structure of terylene or nylon is commonly asked. You need to know some of the chemistry of natural macromolecules such as protein and carbohydrates. Proteins have the same linkage as nylon but have different monomer units to nylon. And when proteins are hydrolyzed, they form amino acids. Similarly, complex carbohydrates contain a large number of sugar units. Students should be able to describe the process of hydrolysis of both proteins and carbohydrates. Now, let us take a look at the command phrases and words that are used in chemistry examination papers. Now, examiners use command terms to help you understand what they are looking for in your answer. So this slide explains what each of these words or phrases mean and guide you towards what kind of answer you should write. Now let's begin with define. If you're asked to define, you need to state the meaning of something. For example, define reduction. Then you just say reduction is the gain of electrons. And what is a hydrocarbon, or define a hydrocarbon? A hydrocarbon is a compound that contains carbon and hydrogen only. So this is how you answer questions when you're asked to define. Next, what do you understand by or what is meant by? Now you should define something and you have to make a more detailed comment about it. Now how much detail you're including depends on the number of marks awarded. You take the number of marks as your clue and write as many points as you want. If you are given 2 marks, just 2 relevant points would do. For example, what do you understand by the term diffusion? State. When you're asked to state, you need to give a short answer without going into much detail. For example, state the name of the compound with the formula CuSO4. Next, list. When you're asked to list, write down the answer as separate points. For example, list 3 properties of metals. You don't have to write more than 3. Now let's look at explain. When you have to explain, you have to give a reason for your answer or refer to a particular theory. For example, explain why reaction rate increases with temperature. Now for this, you need to write your answer using collision theory. Describe. You need to state the main points about something. Describe how you can separate a mixture of colored inks, and your answer will describe, and in your answer you describe the chromatography process. Discuss. You have to write points for and against an argument. Example, discuss points for and against the use of biofuels. Outline. When you're asked to outline, you state the main points briefly. Example, outline the process of extracting aluminum from pure aluminum oxide. So you just have to write about the aluminum, name of the aluminum ore, the use of cryolite, what the anode is made of, what the cathode is made of, and what products are formed at the anode and the cathode. So this is how you answer for outline. Predict. This can be used in 2 ways. You can find the answer by working out the pattern. Example, predict the state of astatine at room temperature. Or it also means giving a short answer as to what might happen next. Example, predict what you would see when compound X reacts with bromine water. So read the question carefully. See what is the command word that is given and write your answer accordingly. Okay, this will help you improve on your answers, and it also gives the examiner a better opinion of the type of answer that you have written. Finally, let's end this session by taking a look at one of the candidates' answer and the examiner's comments. Now let's look at the first question. Protons, neutrons, and electrons are subatomic particles. Complete the table to show the relative mass and relative charge of a proton, a neutron, and an electron. So this question is based on subatomic particles. Now let's look at the student's answer. Now, for the first part, first you need to write about the relative mass, and then it's the relative charge. So this student has got 1 out of 3 marks because the only answer that is correct is the relative mass of proton. The relative mass of neutron should be 1. Okay. Let us see how this answer can be further improved. The relative charges of proton, neutron, and electron need a value such as +1, 0, and -1 respectively, and not as how the student has written in words. So no marks have been given. So out of 5 answers, he only has 1 answer correct. So the mark awarded is 1 out of 3. The entire question carries 3 marks. Now the next one. Bromine has 2 isotopes. Define the term isotope. Isotopes are atoms of the same elements with same number of protons but different number of neutrons. A correct explanation. Okay, next one. Explain why 2 isotopes of bromine have the same chemical properties. So the explanation here should be isotopes of bromine have the same number of outer electrons. Since they have the same number of electrons in the outermost shell or the valence shell, the chemical properties are the same because they come from the same group. Okay, the next one. The table shows the number of protons, neutrons, and electrons in some atoms and ions. Complete the table. So all answers are correct except for one. The student missed out the answer for mass number and so could not get full marks. Okay, so you can see that with a bit of care and effort, you can easily get full marks for questions of this kind. Okay, so that is why, as we say in class all the time, practice, practice, and practice. Practice your past papers and revise your textbook as well as all the notes that has been given to you. You can start practicing by answering questions for the multiple choice questions. Now, once you are quite familiar with the multiple choice questions, then you pass on to your paper 4. Okay, so practice students. All the best in your exam and wish you all well.